Decorator pattern attaches additional responsibilities to an object dynamically, providing a flexible alternative to subclassing for extending functionality. Welcome back to Java Revisited. In today's video, we are going to explore the top 5 system design patterns that every engineer should know. Whether you're a beginner or an experienced developer, understanding these patterns will help you design scalable, maintainable, and efficient systems. So let's dive in. Before we jump into patterns, let's briefly discuss what a system design patterns are. System design patterns are reusable solutions to common problems encountered in software architecture and design. They provide a blueprint for structuring components and interactions within a system. The Singleton pattern ensures that a class has only one instance and provides a global point of access to that instance. It's useful when you need to control access to shared resources or manage global configurations. In order to demonstrate a Singleton class, here's a code for it. First of all, you create a project and make sure to create a Singleton class within a private constructor like this, and then you also provide a static method to access that instance, this one, and then use a lazy initialization to create instance on demand. So we have it here, right? If I run this code, you will see that you get the output as a singleton class, singleton instance, right? So this is very simple how you can use singleton class, and how singleton class ensures that a class has only one instance and provides a global point of access to that instance. It is useful when you need to control access to shared resources or manage global configurations. Let's go to the next one. The factory method pattern defines an interface for creating objects that allows subclasses to alter the type of objects that will be created. It is useful when you want to delegate object creation to subclasses or encapsulate object creation logic. For demonstration, let us create an interface or an abstract class for the product, like so, and then we define a factory method in the creator class. This is the factory method, we define it, and then we have subclasses that to implement the factory method to create subspecific product. We have product A, product B, then we have creator classes like so, yes, and finally we have the main, where we create an instance of creator and we will run it to see what happens, the output. There you go, you have the output as using product A and using product B. So this is how factory method pattern is widely used in frameworks and libraries to provide extensibility. The observer pattern defines a one-to-many dependency between objects, where one object, the subject, notifies its observers of any state changes. It's useful when you need to maintain consistency between related objects or decouple components. The observer pattern is commonly used in event handling, UI components, and distributed systems. Let's see a code demonstration to understand this. So let's define a subject interface with the methods to register, remove, and notify observers. Then implement concrete object classes Concrete or subject classes that maintain a list of observers and notify them of the state changes. Then we implement the observer. Interfaces with an update method to respond to notifications. We run the main class. And there we go, we get observer 1 received, hello observers, observer 2 received, hello observers. You can find this code in the description, so you can check it out. This is how we work with observer pattern in event handling, UI components, and distributed systems. Next up, we talk about the builder pattern. The builder pattern separates the construction of a complex object from its representation, allowing the same construction process to create different representations. It is useful when you need to create objects with many optional parameters or configurations. We create a builder interface with methods to set object properties, and we implement the concrete builder classes that provide fluent interfaces for setting the properties. If you see, we have the product class, and then we have the builder interface. Then we have the concrete builder. We have the director, and then the main. We run the main. So we run the main method to see the output. And then we have product part 1, part 2, part 1, part 1, part 2, part 2. So this is your output. So the builder pattern is commonly used in object creation scenarios such as creating immutable objects or configuring complex objects. Now comes the decorator pattern. Decorator pattern attaches additional responsibilities to an object dynamically, providing a flexible alternative to subclassing for extending functionality. It's useful when you need to add or remove behavior without modifying existing code. Let's see how this would work. A decorator pattern is commonly used in GUI frameworks, IO streams, and logging. Define a component interface representing base object. Implement concrete component classes that provide basic functionality. Create decorator classes that wrap components and add additional behavior. So here we have the component interface. And create a concrete component that implements the component, and then we have decorator class which implements the component, and we have concrete decorators like decorator A, decorator B, and of course the main. Then we run the code. And you can see here concrete component operation, concrete decorator A, additional behavior, concrete decoration B, additional behavior. Simple. So this is how we can work with it. The decorator pattern is commonly used in GUI frameworks, IO streams, and logging. And there you have it. We have explored 5 essential system design patterns: Singleton, factory method, observer, builder, and decorator. Understanding these patterns will empower you to design better software systems and tackle complex engineering challenges with confidence. Thank you so much for watching, and if you find this video helpful, please like, share, and subscribe to Java Revisited for more programming tutorials and system design insights. Happy coding!